Alright, Caitlin, I'm going to try to show you some of 9.4c here. So one example you'll see will be laid out like this. To rationalize the denominator, what you need to do is multiply by what's called the conjugate. So we're going to take the denominator, basically rewrite it as is, but you have to change the sign. So if it was a negative, you should make it positive. If it was positive, you'd make it negative. And we do that because you'll see these radicals are going to cancel out, because you're not allowed to have a radical in the denominator like a 0. So you're just going to have to FOIL. So I'm going to do the numerator first. Square root of 3 minus 4 square root of 7 plus 7. The square root of 3 times square root of 7 is just square root of 21. Square root of 3 times 7 is just 7 square root of 3. Negative 4 times the square root of 7 is minus 4 square root of 7. And then minus 4 times 7 is negative 28. Okay, that's going to be your new denominator, or numerator I should say. And then your denominator is the square root of 7 minus 7 times square root of 7 plus 7. So square root of 7 times square root of 7, square root of 49. Square root of 7 times 7 is plus 7 square root of 7. Then we take this negative 7 times square root of 7, which becomes minus 7 square root of 7. And negative 7 times 7 is negative 49. Okay, this is nice because it's a perfect square. Square root of 49 is 7. These cancel out by design. And then we have minus 49. Okay, and 7 minus 49 is negative 42. And that would be your final answer. It's ugly, but it is more correct because you don't have any rationals in the denominator. Now Hawks is going to prefer you to move this negative out front, just center it in front. So that's where I would put it when you're typing it in. So that's one example. Just gonna make sure it's still recording. Alright. Okay, another example you'll see is if you have something like this, the square root of 3y over 5x. Okay, anytime you have a big root like this, you're allowed to break it up to like the square root of 3y over the square root of 5x. If you can simplify in here first, you should, but 3 and 5 don't simplify, and y and x don't simplify. So I would just go ahead and split it up. Now again, we have a rational in the denominator, that's not allowed. In this case, there's no pluses and minuses. So what we're going to do is we're going to multiply by a very clever form of 1. Okay, you're just going to multiply by itself, because then it'll be a perfect square in the next step. And so now, our new numerator is going to be square root of 15 xy, and our new denominator is going to be the square root of 5 times 5 is 25, x times x is x squared, which can be simplified, which is the whole point. So this numerator isn't going to change at all. It just is what it is. If we could simplify it, we would. And then here, the square root of 25 is 5. The square root of x squared is x. So that would be your answer. Another one, kind of similar. It's the square root of 18 over the square root of 3. Just like last time, you can't have this radical down here. So we're going to multiply by square root of 3 over square root of 3. We're allowed to do that because anything divided by itself is 1. We're not changing the value. So now in the numerator, it's been a long day. We'll make sure I don't mess up any mental math. Yeah. This is going to become 18 times 3 is 54. And then 3 times 3 is 9. And now we can simplify. The square root of 9 is just 3. And the square root of 54 can be simplified. So you just need to break it down into its prime factorization. So it's even. So if anything else, you could just break it down by a factor of 2. I circle my primes so I don't lose them. You don't have to do that. 3 times 9 is 27. 3 times 3 is 9. So I can rewrite the square root of 54 as the square root of 2 times 3 times 3 times 3. And then we're looking for pairs underneath. You might do this differently. Some people look for perfect squares. That is a perfect square. 3 times 3 is 9. If I take the square root of 9, I get 3 on the outside, and then 2 and 3 didn't match up. They're not perfect squares with anything. So 3 times 2 is 6. So the square root of 54 became 3 square root of 6. And finally, for the last step, 3 and 3 cancel, and so your final answer is just the square root of 6. Just making sure you can actually see. All right. Similar one. Here's one that's going to reverse that property that I showed you with the square roots. So this is 100 by and 25 by. So before you had one big square root, and I told you you could split it into numerator and denominator. It works the other way too. Just temporarily. Sometimes it's useful to stick them together because you can cancel a bunch of stuff and make your life easier if you cancel up front. So like b cancels with b, y cancels with y. 100 divided by 25 is 4. And then your answer is just very simply 2. So instead of trying to deal with all of this up front with the big numbers, it's perfectly legal in math to do what I did by putting it together, simplifying, and then just taking the square root of the smaller number. Looking to see if there's other examples. That's mostly the problem types you'll see. You had also mentioned 10.2. You don't have to worry about I. We're not doing any complex numbers in this class. In college algebra you will, but not here. So, let's see. Let's do one of these. So you will have to memorize quadratic formula. It's opposite of b plus or minus the square root of b squared minus 4ac all over 2a when you're dealing with a trinomial set equal to 0. Okay, so an example would be if you had, put it up here. Negative 7x squared plus 3x plus 1 equals 0. If you ever have an equation not equal to 0, just move stuff over to the other side of the equation using the opposite sign. So in this case, my A is negative 7, my B is 3, and my C is 1. So when we go to plug in, this negative is part of the problem, the opposite of B. So since I had a positive there, I need to have a negative there. And if I had a negative B, I'd want a positive here. And then B squared would be 3 squared minus 4 times A is negative 7 times C is 1 all over 2 times negative 7. Okay, the hardest part is getting all of this correct. So this 3 squared is 9. And then you can either consider this to be negative 4 times negative 7 times 1, and whatever sign you get, you put here. Some people like to put the minus down and just multiply these, but then sometimes you get minus and negative and have to make it a positive. So usually I just do, in my head, negative 4 times negative 7 is positive 28 times 1 is still positive 28. Okay. 9 and 28 is 37. It's way too long. And then 2 times negative 7 is negative 14. 37 isn't going to simplify, but if you could, you should. And then, let's see, the only other thing you can do here is because you have negative over a negative, and then the plus minus, you can remove these and let this be your final answer. And then just one more thing I'll show you. Like sometimes when you get to the end of that, you'll have something like this where it's like 2 plus or minus 2 square root of 5 over 2. Okay? You can think of either pulling the 2 out front and then canceling, or some people like to just think of all 3 zones getting simplified by a factor of 2 all at once, which is really just 1 plus or minus square root of 5. Just don't touch underneath the radical, and make sure that you have a coefficient to cancel with there too. So like another case would be, let's see, if we had 12 plus 6 over 3 over 3. Okay, you can't touch this with the 12, the 6, and the 3 all are common, have a common factor of 3. So you could cancel. And this would become 4. Oops, that should have been a plus minus. Plus or minus 2 root 3. So if you have an answer like this and you don't see where it's saying it's not simplified, or on the final you don't see your answer, you might just have to simplify. Okay. Hopefully that helps. If you need any more, just let me know and I'll do my best to try to explain to you. Have a good one.